All right, one way of doing this question would be to write out the numbers from 1 to 20 and then start maybe circling the primes, the triangle numbers, and so on, and trying to find the pattern. Another way is just to focus on one of them. And actually, there's not that many triangle numbers. There's more prime numbers less than 20 than triangle numbers. So let's focus on those. Triangle numbers are when you, let me just show you. Here's the first one is just 1, and then you start building it up into little triangles. So you add 2 to give 3, and then you got 1, 2, and then your bottom row is 3, so you have 6, and so on. The next one you'd add 4 to give 10, and the next one you'd add 5 to give 15, and then you'd add 6 to give 21. So those are the triangle numbers, and those are the last numbers we have in our consecutive positive integer groups. So I'm then going to write down the ones that go before it. So it would be -1, 0, or my consecutive numbers, 1, 2, 4, 5, 8, 9, and then 13, 14. So now we can just quickly check which ones work. Well, they have to be positive, so we can rule out that one. And then I'm going to check all the first ones for if they're prime. 1 is not prime, so I can rule it out. 4 is not prime, so I can rule it out. And 8 is not prime. And actually, I'm done. I've got 13, 14, 15. Let's just check it though. 13 is prime, 14 is even, and 15 is triangular. I'm actually asked for the products of these three integers. So one thing to do would be to actually figure out that product. If you want to be really speedy, however, we could use a process of elimination. 4 times 5 is 20. This number is necessarily going to end in a 0. So I can rule out that one and that one. Next, I already see when I do 13, well, basically this is going to be bigger than 1,000 because 10 times 10 times 10 is equal to 1,000. So this must be greater than 1,000, which means I can also rule out 60 and 990. So the answer is going to be E. If you want to check, then of course, yeah, calculate it, but we're done.